Hello everyone, this is Space Cafe Podcast and I am Marcus. I like serendipity, those inconspicuous moments that slowly grow on you and suddenly make sense. Like the other day at the South by Southwest conference I was invited to, there was this talk by Amy Webb, who has long since become a household name at the conference with her technology outlooks on the next few years. When she presented her 600-page oeuvre this year, she also talked about how she puts herself in work mood with brown noise. Not knowing what that was, I immediately subscribed to a playlist on the streaming service I trust, and voila! No more distracting noises, less temptation to do anything but my work. So what sounds like a sales pitch is not. Brown noise can be found everywhere on the web, and you could even make it yourself. Just try it out if you like. Back to serendipity. Our guest today also falls in this category. I was actually looking forward to an exciting conversation about 3D printing and its future in space travel. But as it's sometimes here the case at Space Cafe Podcast, we drifted and suddenly found ourselves in the middle of the African jungle on a Table Mountain with a rocket and, last but not least, world powers that did not like this colorful hustle and bustle very much. Ladies and gentlemen, I'm very pleased to introduce my guest, Lin Kayser, today. Lin is a serial entrepreneur who lives and works in Munich. He has a fascinating family history and possibly the key to a new generation of space technology. Lin, thank you so much for taking the time to be on our cozy show, Space Cafe Podcast. Let me jump in here with a question regarding your TED Talk you did a couple of years ago, that is. And you showed a piece of metal. And the interesting thing about this piece of metal is that it is of no human origin. No human lay his hands or her hands on that piece of metal. And it turned out to be a rocket engine. And so the obvious question is, does it fly? And where does it come from if no humans have ever laid their hands on it?
First of all, hi, Marcus. Thanks for having me. It was a little bit tongue-in-cheek. Of course, there are humans behind it. But it is one of the first objects, man-made, let's not call them man-made, one of the first objects that was not designed directly by a human engineer. It was designed by a computer, right? And when you look at it, it looks kind of alien, right? The interesting thing is what we're doing with my company, and I have a company called Hyperganic. We design objects using artificial intelligence and then produce them in digital factories using industrial 3D printing. And the interesting thing is that when you do things like that, you end up with shapes that look kind of organic, but are also not really organic. I mean, they're kind of hyperganic. That's why we call the company like that. Mm-hmm. And they have the potential to be way more efficient and way more intricate than what we usually design as humans, because we humans always try to keep things simple.
Do you tell the machine, I want to fly to the moon? Please design the proper vehicle?
At some point, hopefully, yes.
That would be something.
That would be something. And this is actually, I mean, you kind of summed up our vision in a nutshell. We actually think that engineering should be automated. But, I mean, let's come back to reality in the year 2021. I mean, right now you have to tell the algorithm how a human would design it. But once you've kind of encapsulated this human knowledge about how you design things into a computer algorithm, then this computer algorithm can work tirelessly day and night on, if you want, hundreds of computers to come up with the optimal shape for something. And that automatically almost results in things that are more interesting than what a human who has limited time and limited knowledge will design.
Has it ever flown, this non-human made rocket engine? Has it ever flown?
This one not. I mean, this was a demonstrator. We did that 4 years ago almost. We work on space hardware with customers. So we have not shown this publicly, but we have space hardware that will fly. This one will not fly, and it's one of the reasons. I mean, we intentionally exaggerated some of the features also because rocket technology obviously is a very sensitive area and you can't show certain things just publicly. But no, I mean, this was a demonstrator and this will never fly because there's a lot of assumptions that we took that are probably wrong. I mean, we did it together with aerospace engineers, but today we work with leading aerospace companies and we produce objects that will fly. Yes.
I mean, like, you're right up the alley of what Elon has been doing for quite a while now, taking bold steps. We all remember his Cybertruck feat he pulled off where he almost destroyed the bulletproof car window. That was kind of cool. But still, it did the job and made the piece interesting and resulted in quite a bit of global interest. So I think very often it's about making a bold statement. And I think this rocket engine produced or envisioned by Hyperganic is something like this.
I mean, first of all, I have a huge respect for Elon Musk. I mean, what he's created over the past decades is just mind-boggling. I'm always very careful with comparisons. I don't want to even go anywhere there. But I think what he does, and this is really important, he just goes for it. He throws away all the assumptions about certain things and just says, okay, how hard can it be? And that's his brilliance. Then he executes like crazy. I mean, this guy works like a madman and he is so smart and he's a great executor. So you can have all the visions and all the ideas in your brain. It doesn't matter if you can't execute, if you can't bring it into reality. And this is actually what impresses me the most about him. Now, I mean, we can all aspire to kind of try to get more stuff done. That's in our brain, and I certainly try to. And I think part of it is actually that you inspire people, that you show people what is actually possible. And so I think in Germany, where I come from, most engineers will always tell you what's not possible. And they are often right, but it's kind of becomes a very depressing world when you only think about the stuff that's not possible. So I love that Elon focuses on the things that he thinks are possible and then makes them happen. And we certainly aspire to do similar things, right? I mean, you're right. Wonderful. I mean, it's a bold statement. It's a bold statement in a way, but it is also a statement we followed up on. And so it's not just a gimmick or some showpiece. It's actual technology that we back then already knew was working. And we have proven this over and over again. And we can't wait to show more of these examples to the world. We've been doing in stealth mode.
Stealth mode. I like that. So I hope we can go a little bit under the hood in the next couple of minutes. But let's take it with a grain of salt, of course. But your very un-German approach has its roots in your own family history. And so in order to understand why you do what you do and how you do it, we need to understand where you come from. But before we go into that, let me just sum up what I believe drives you is the basic premise that we are, as a society, as humans, we are not innovating fast enough. And this is why you found Hyperganic. Is that about right? That we cannot keep up with the way we innovate with software? Now, the hardware needs to get up to speed in the same pace of innovation cycles. Is that about right?
Yeah, I mean, that's a good summary. I mean, so I grew up with the PC revolution. I taught myself how to code when I was 8 years old because I found some books and some magazines that told you how to write basic code. I didn't have a computer. I wrote it in a paper notebook at the beginning. That was kind of funny. But I witnessed the entire PC revolution from 40 years ago to what it is today. And I was always, I actually never really thought about it because it was just normal. But if you think back, it's amazing what has happened. 10, 12 years ago, nobody had a smartphone. 20 years ago, very few people used the internet. 30 years ago, very few people had a PC. Amazing what happened in just a couple of decades. And I've witnessed that all. And one of the things that I always got kind of frustrated about is why all the other things around us that are not IT, information technology related, why are they more or less very similar to the things that were around 50 years ago, 30 years ago, 20 years ago? And I researched that. I looked into that because I think we're running out of time with a lot of the challenges of our times. And increasingly, the future that we kind of have to predict from where it's going looks like a very depressing place. And this is like in a stark contrast to what I thought would happen when I grew up as a kid. I thought there will be space stations and free energy and all of these things. And instead, we're headed right now towards a future that, where climate change is dominating everything. And then like this, a lot of these big societal problems are actually becoming worse. And there's more inequality because there's a race for resources and all of these things that you read on the news all of it every day. And part of it is just how news works. But to a certain extent, it's very right. We are actually running out of time on a lot of these issues. And so I think the only way we can solve that is to out-innovate.
At the same time, we're evolving. And I mean, like sometimes it seems like we're evolving backwards in certain aspects.
Oh, it's very true for space. I mean, if you think about it, I mean, before Elon came along, I mean, we were basically able to fly to the moon in the 60s. And then we had the space shuttle, which allowed us to go, to low Earth orbit. And then the Americans actually didn't have a space shuttle anymore, and they had to rely on Russian capsules that were invented in the 50s and 60s to shuttle people to the space station, which the space station is a very cool thing, but it's flying very low. So it's not actually that interesting compared to where we were in the 60s and 70s. A lot of stuff seemed to be moving backwards. I mean, if you look at the car manufacturers, they seem to be busy inventing new sounds that the mufflers make when you step on the gas instead of coming up with something that is maybe more innovative. So where were the flying cars? Now, all of a sudden they're happening. And I would say that we see a resurgence in innovation and visions for the future that are positive. And a lot of them actually are driven by Elon. Like I said, I have a huge amount of respect for this guy because he single-handedly moved a lot of these industries forward, and not just with dreams, but with actual reality. But yeah, I mean, what I think what we need to do is we need to get much faster in innovation in physical objects. It's ridiculous that we are still basically designing physical objects the same way the Romans did it. So you sit down as a smart engineer and you put it basically on paper. And that's how you do it today. You're not using paper, you're using a computer, but it's a very similar process. What you invent, what you create as an engineer is limited by your knowledge. So there's no networking. It's not like if something better gets introduced somewhere else, immediately it's available like we have it in computer technology. And it's manual labor. I mean, the complexity of the object that you create is directly related to the amount of work that you put into it. And that's just a completely ridiculous model if you think about it. And we should be much further along. And I was kind of wondering, why is nobody doing that? And then at some point I realized maybe that's what I should be doing. And that's how Hyperganic was born.
Let's get back to perhaps how it all started and why you have it or seem to have innovation and the bold steps in your blood. And I'd love to talk about your uncle because you seem to have an interesting uncle, I think. To understand you and your life, we need to understand your uncle. So let's talk about Lutz Kayser.
Sure. I mean, Uncle Lutz, he was one of the craziest guys that you can imagine. I mean, he was kind of the Elon Musk of the 1970s. He started a company called OTRAC in the 1970s, Orbital Transport Raketen Aktiengesellschaft, so Orbital Transport Rocket Incorporated. And he started building cheap, privately financed rockets for orbital transportation, so launching satellites into space. And he was actually quite successful with it. And, he was a true pioneer. I mean, he raised 400 million Deutschmarks, so about 500 million euros in today's money, from individual investors. So not like big time investors, from dentists and lawyers, and Wim Tölke, the TV moderator, was an investor.
Interesting.
Yeah, so he had like hundreds and hundreds of investors, and
it was like a crowdfunding spirit.
That was crowdfunding, actually. So he did that. That's how he financed his rocket company. And then he started launching these rockets in Africa on a launch pad that he leased from Zaire's dictator, Mobutu Sese Seko. So Zaire today is Congo, right? And he had leased a piece of land in Congo that was as big as Austria. I mean, just for size, try this for size.
So hold on, Lin. So he went to this dictator and he said, I'd like to launch my rockets in your country. Can I do that? And the dictator goes like, okay, here's a piece of land.
Fundamentally, yes. I mean, the story is kind of a little bit more involved and actually quite funny. So my uncle was a bit of a playboy. And he met the boxing promoter in Paris who organized the Rumble in the Jungle, Muhammad Ali against George Foreman, the boxing match. And that actually that took place in Zaire, in the Congo. And so these two guys have a conversation. And my uncle says, we need a launch site for our rockets, which is close to the equator. We're looking into South America. And the guy says, have you looked into Africa? Because, well, there's a lot of land near the equator. And actually, I happen to know the president of the Republic of Zaire. Do you want to talk to him? And yeah, that's how they talked to him. And of course, Mobutu was quite excited. I mean, you have to imagine there was a time when only Russia and the United States were able to launch satellites. So that's not that far after Sputnik and the first satellites and spy satellites that were launched by the United States and Russia. And nobody else was able to do that, let alone a private company. And having a Cape Canaveral in Congo, I mean, that was really attractive to an African dictator. So that's what he did. And my uncle had a huge influence on my life. Simply by example, I didn't meet him that often because he was always flying around in his Learjet and landing on dirt landing strips in Africa. But in my grandmother's living room, there were pictures of rocket launches hanging there. Not pictures of the grandchildren like in most living rooms. There were pictures of rocket launches. I still remember this one picture where you saw the sequence of this rocket going off. And I mean, it's kind of funny because as a child, everything that's around you is kind of normal, right? You grow up in a family and everything is normal because that's what you experience. You can see that some people grow up in weird families and you kind of wonder why isn't the child saying something? And yeah, because it's normal. And for me, in the positive sense, of course, it was completely normal that my uncle launches rockets in Africa. And so it had a huge impact on me. So it
was like just another family member going to work.
In a way, yes. I mean, it was kind of clear that my uncle was someone special, but it wasn't as clear as it is today what a unique human being he was. And that there's probably not that many people around who can do stuff like that. I mean, he flew to the jungle and built a rocket facility there. And it was like in the middle of the jungle. There was nothing there, no infrastructure. So he bought a construction company that had experience of building stuff in Africa called Stevering. And then these guys went on an expedition moving all the heavy equipment through the jungle. And it's such a hilarious story because, it was actually not that difficult to move it through the jungle because if you have a construction company and all this heavy equipment, you can actually build a road as you go through the jungle. Now, that's what these guys did. But there was nothing there. And then they built an airstrip and then they landed heavy. He bought airplanes, freight airplanes. He was infamous for flying out of the jungle towards München-Riem, Munich airport back then, and just arriving there and saying, "Hi guys, can I land here, please?" without filing a flight plan or anything. Yeah, he was
true pioneering spirit. Yeah. True pioneering spirit.
Absolutely. And if politics hadn't shut him down back then, because he was getting caught up in this whole Cold War politics and French politics that wanted to establish the Ariane rocket, he would have succeeded. I mean, his rockets, they were flying and there was fundamentally nothing wrong with his approach.
So he was sort of even rivaling the Ariane project. So that's already a sign and a very clear indication that that was just not another backyard project, so to say. So what was your uncle's asset when it comes to rocket technology? What was it that made him so successful? Did he have a specific kind of technology he was trying to put to market?
Yeah, absolutely. I mean, his idea was low-cost rocket technology, really low-cost rocket technology. He said he was highly critical of the government-led space programs. Actually, a lot of the things that we hear today in new space, I mean, my uncle all said this 50 years ago. So, for example, most of the government rockets, they work on a cost-plus model. So basically, you charge how much it costs, and then you get a markup of, 20% on top of that, and that your revenue as a rocket company in government-led projects. He always said this is ridiculous. This will always lead to this stuff actually becoming way more expensive than it should be. So what he said, right now we are flying stuff into space with Rolls Royces, but you need a truck. You need a truck that just is the cheapest way possible to move this stuff up into space.
Does the heavy lifting.
Yeah. And so he used standard parts. So it's funny, Elon is now using stainless steel to build his Starship. My uncle used stainless steel pipes from the oil industry as a standard part. Because you could have them very cheap. He made pressure-fed rockets that were fed through pressurized nitrogen. Instead of building turbopumps, he wanted to move the rockets. Instead of gimbaling rocket engines, he just used differential throttling. He used windshield wiper motors for controlling the valves. Because what does a windshield wiper motor do? It goes in one direction, then back in the other direction, very reliably, hundreds of thousands of times. So he put that into the valve.
So it was sort of an off-the-shelf approach.
Yeah, very much. I mean, there was a lot of custom parts, of course, the engines and stuff like that. They used off-the-shelf parts whenever possible. And these rockets were just dirt cheap. So they would have completely revolutionized orbital transport. There were a lot of criticism about his approach because he never looked at maximum performance. He always looked at how can we get this done as cheap as possible. And I think he would have needed a lot of additional iterations, and maybe some of the assumptions that he took would have had to be corrected. But these rockets would have flown because they were starting to fly. I mean, his rockets, I think the highest test that they did really at the end was like 80, 90 kilometers. And yes, there's still, of course, a gap until you get to orbit, but this was a single stage. He wanted to massively stage these rockets, and I'm very positive that he would have succeeded if politics wouldn't have shut him down.
What became of the project? Did it completely vanish under the forces of international politics?
Yeah, pretty much. So, the Americans hated this, the Russians hated this, and the French hated it. Because the French tried to push Ariane. And today, if you can look at the letters that were going back and forth between Charles de Gaulle and Helmut Schmidt, so the French president and the German chancellor at that time. So Charles de Gaulle was pressuring Helmut Schmidt to shut down my uncle because he felt it was a politically terrible thing that this private company was basically infringing on the turf that should belong to the government. The French wanted to be the third government that launches rockets into space after the Russians and the Americans, of course. And so my uncle...
If presidents and chancellors want to shut you down, you're onto something.
Oh, absolutely. It's just a question of whether you can actually survive, right? There were a couple of things that happened. First of all, there was an invasion by Angola, actually targeting the area where my uncle had his rocket launch facility. And that became really hairy. And my uncle hired a couple of guys from the Foreign Legion to actually protect him, but he wouldn't have been able.
Of course, what else would you do?
Yeah, you're in the middle of nowhere, and there's Angolan soldiers walking towards you. So what do? You find some protection, yeah. And Mobutu couldn't do anything about this because it was a really remote area, and he didn't have a big army. So he finally asked the French for protection. And the French sent in the army, they sent in paratroopers, to fight the Angolan soldiers back. But one of the conditions that they had was that Mobutu shuts down this area. And the other thing that they did in Germany is, in Germany we have a really obscure law, a really obscure tax law. So there's a tax law that says, if you don't make money with your business within 5 years, it's not a business, it's just your fun project. It's your hobby. And so all the money that you have deducted from your taxes, you have to pay back to the tax authorities. And they used that law against my uncle. So of course a rocket company after 5 years doesn't make money, right? I mean, there's still a lot of, still a lot of money that needs to be spent. And they used that law. I mean, why does that law exist? I mean, first of all, let's understand why that law exists. Imagine you buy a washing machine, right? And you claim you have a washing salon. You have a business washing clothes, but you never actually sell that service to anyone. You just use it to wash your own clothes. This is why this law exists. At some point, the state will say, wait a second, you can't deduct this washing machine from your taxes. You only use it to wash your own clothes. This is your hobby or your personal fun thing, but you never intended to have a business. This is why that law exists, so that you can't just claim I have a business and you actually use the stuff only for yourself. But of course, they used it against my uncle and they basically shut him down because they basically said, dear Otrak, you have to pay back all the tax deductions that you took while developing this technology, because it's not a business, it's just a hobby. And and that's how they shut it down.
Fascinating. And so what became of the intellectual property that your uncle and Otrak developed?
There was a little bit of a contentious point. So Otrak said it belongs to Otrak, but they didn't do anything with it. My uncle said it belongs to him because there was a contract. In the end, nobody ever did anything with it. But it's a fun fact. There was John Carmack, the founder of ID Software, the guy who... Doom, exactly. He had a rocket project a while back. And my uncle and him, they kind of hit off. And my uncle actually traveled to him and gave him a couple of pieces of space hardware that he developed. And John incorporated it into his rocket. And it is a fact that John was actually the first one to land a rocket backwards again after it had flown. And it kind of became the inspiration for Elon to do the same thing with the Falcon rocket. So John's project, it was called Armadillo Aerospace. Yeah. And they had these hoppers that flew up and down and up and down. And it kind of, Elon saw that and said, wait a sec, maybe we can actually do that with an orbital rocket, which is like immensely difficult to do. But so there's space companies are all connected. But my uncle lived in the U.S. Marshall Islands until 2017 when he died, and that was actually very close to where Elon launched his first rockets on the Quach Atoll. And I remember my uncle calling me, and he never called me. I mean, he was such a remote person, actually, a very private person. So he called me and said, Lin, you wouldn't believe it. There's this crazy internet guy who is launching rockets close by. What a nonsense. So this guy will never succeed. I remember, he thought he was like a complete fraud, like a complete idiot. Look at this guy who did internet services for finance. And now he's launching rockets. This guy will never succeed. Famous last words. So, yeah.
Sure. Wonderful. Wonderful. So we should point out that there is a beautiful movie out there about your uncle, and it's titled Fly, Rocket Fly. So I highly recommend watching that movie. So where is it available, Lin?
Oh, you can buy the DVD, and it's available on Amazon Prime and a couple of other. I think it's in some locations also available on Vimeo. I don't get any royalties or anything here, but it is one of the most fascinating stories you will have ever heard. And it is right out of a James Bond movie. And the cool thing about it is the second in command of my uncle, his COO, he was a passionate 16 millimeter filmmaker. And he shot lots and lots of film material, and the movie consists mainly of that material. And it's just,
awesome.
If somebody tells you that story and you thought it's fiction, you would say, it's so improbable and nonsensical. It's a really bad book, but it's all true, and it's part of my youth. Yeah.
And it makes me feel like I'm leading the most boring life imaginable in comparison to what your uncle did. Seriously. I mean, like, that's the epitome of adventure.
Absolutely. I mean, when I look at the cover of Fly Rocket Fly, I mean, it looks like a movie cover. But I can say, no, this is my uncle. This is Aunt Susie. You know,
that's real.
So I know them all, but it looks like,
wow.
Like I said, like a James Bond movie.
Wow. Lin, let's get back to the present, to your life. In how far has your uncle influenced you and your own life, an entrepreneur?
I mean, first of all, compared to my uncle, I lead the most boring life ever imaginable because the contrast is just so stark. I'm aspiring, but so far, so good. Anyway, no, I mean, it was clear to me from a really early age that I would become an entrepreneur, except that I, of course, had no clue what that meant. Right? I mean, I had some rough understanding that it involves flying around with a Learjet in Africa. But I mean, the sad thing is nobody tells you what an entrepreneur actually does. You never learn it in school. It's one of the most interesting things you can do, but you actually don't know what it is. And I had to learn it. And fortunately, through like a complete coincidence, serendipity, my first job, which I just took to basically finance the beginning of my studies in Munich, my first job was in a startup. And that startup, I didn't know what a startup was. It was a small company, cool guys, a lot of respect for the founder, Thomas Vetter, a company called Aradex in near Stuttgart. And they had this idea that you could use PCs to create industrial control systems for big industrial machines like milling machines and stuff like that. And everybody thought that was like a completely ridiculous concept because everybody knew you had to build special hardware for that. And I stumbled into that, and I thought it would be like a little part-time thing that I do next to my studies. And all of a sudden I was working 14-hour days and building up their software department for 7 years and working very closely with the CEO on making his ideas a reality. And that was, I would say, one of the most important other influences in my life, that I actually learned the trade of being a startup entrepreneur as in my early 20s. I was 22 and here I was working in a startup and nobody knew what a startup was back then. And that was very, I mean, this together with the spirit from my uncle, I think that helped me kind of, get my bearings a little bit. And then in 2000, I started my own startup and in a completely different field, in the field of Hollywood movie making, digitizing the international film industry, specifically the US film industry. We built the first digital cinema with our software for the Matrix movies and then went on to basically, I mean, if you've been to the movies in the last 20 years, our technology, our image processing technology was involved somehow. I sold that company to Adobe in 2011. So it lives on in these products. So I think I had the huge privilege, to have good role models. And one was my uncle, but he was more abstract because, he wasn't part of my daily life. He was more like this, idol that was kind of remote and doing these crazy things. And you had no idea how he actually did these things.
And whenever you visited your grandmother, you would see on her wall the rockets. And you got reminded of your uncle doing his thing in dangerous places with snakes and crocodiles.
Exactly, literally. And I spent hours and hours, entire days in the basement office of my uncle. He had all these books about space technology and I read them all. I still have a lot of them. Books hand-signed, autographed by Hermann Obert, one of the early space pioneers and stuff like that. So I grew up with space technology and I'm a space buff. But like I said, I had this other influence that I think what I learned from my uncle is a healthy disrespect for the status quo. So a lot of people think that the status quo is some kind of system that you have to fit in somehow. And then something naturally evolves in the status quo and then you have to fit into that. And what my uncle showed me, and also what Thomas, the startup CEO, showed me, was that the status quo is just some random thing, and you can just sit down and think about what the status quo should be. And if it makes sense, and if you have the technical prowess to actually do that, then you can change the status quo dramatically. And that's what my uncle did, and this is what Aradex, this early company, did that I worked for.
Wonderful. So let's quickly fast forward to Hyperganic, because your interlude in the film industry and revolutionizing the film industry by digitizing their processes was an interlude. You made it possible that Hollywood digitized itself. I mean, like, you were part of that movement. You didn't do it single-handedly, but you were one of their pioneers. That is important to say.
Absolutely. And it was a huge privilege to be able to help with the transformation of an entire industry from analog to digital. And it kind of, I mean, if it's so funny, if you look at my life, it makes no sense, right? First I do industrial machines, then I do Hollywood, and now I do 3D printers. But actually, if you look back, it makes complete sense how I got from one thing to the next. And, if you look at what we're doing today, it's kind of the combination of both of these things. Image processing, moving pixels through computers that are actually too slow to do that. Now we're doing it with voxels, three-dimensional particles. So we dissolve objects into their particles and then move the particles around and create incredibly intricate objects that look almost natural. So we're using a lot of the thoughts and the ideas from the Hollywood days for that. And of course, connecting it to the printers has a lot to do with what I did early in my life, helping control industrial machines. So it actually always makes sense if you look backwards. And I'm working also with the same team, more or less. So now the team has grown a lot, so lots of new people. But the founders...
The fun thing is that what you're describing, especially in Germany, also in Austria, where I live, at the labor offices, they would tell you that you're inconsistent in your biography. Is that something that you're experiencing also, that the environment is sort of a hindrance to making parts of Europe, and Germany is a large part of Europe, be more innovative as compared to parts of China, of course, and of course the Silicon Valley places and people. So what would you say?
I think Silicon Valley is like a weird aberration. So I don't think anything compares to the Silicon Valley. And the Silicon Valley of today is not the Silicon Valley that it used to be 20 years ago, or whatever. I don't think it's a particularly German thing. I mean, it is a very German thing. You're right. I mean, you have to, do this, and then you have to do this. And there's always a plan, and it's exactly, how you do it. And there's no other way. This is very German. But, actually in China, very much so. In Asia in general, people are very focused on their CVs and, to build their career and make it very consistent. Oh my God, don't have a gap in your career. This is horrible. Oh my God, it would be such a better world if people were not so worried about their careers and doing all the right things. We actually actively hire people who have really weird CVs. My director of advanced projects was a professional breakdancer for 15 years. Yeah. I mean, think of having that CV in a large German enterprise in front of you. Okay, I'm a professional breakdancer, and then I built a company that did 3D printing, and then I was a model builder, and then I made shoes. And so this is Pete's CV. And he's an amazing guy. So, I mean, we hire exactly these people, and I love working with people who are weird and geniuses and can't work in any other place but ours. And this is how you actually move stuff forward. And like I say, I can only encourage everyone to have a really weird CV, because if you're driving down the Autobahn at 200 kilometers per hour, you actually don't see that there's lots of interesting stuff to the sides. So if you slow down a little bit, and if you kind of, embrace these serendipitous,
look around.
Yeah, exactly. Serendipity. Then you get to way more interesting places. And I mean, if you just follow your plan all the time, what happens if your plan is wrong? That could be horrible.
Lin, let's talk about Hyperganic, your current and most important endeavor, I understand. So On your website, you're hiring. Who are you looking for?
Oh, we are looking for all these weird people that can't find a job elsewhere. No, I mean, I shouldn't say that. Now we get lots of applications for weird people. No, I mean, we're looking for people who really want to change the world. And I know that everybody says that now, and it's kind of become like, such a hollow phrase. But, this is really what we're doing. What we believe is that the next 10 years in manufacturing and creation of physical things is going to be changing more dramatically than what we've experienced in the last 100 years. The last 100 years after the Industrial Revolution were really incremental. Lots of cool stuff that happened, but, very incremental. You could kind of, if you look at it, you could kind of foresee that it would go into that direction. We produce objects very similar to the way we produced objects 100 years ago. It's just more automated. Now, actually, it's not that dissimilar to how we produced objects in the Stone Age. And now with the advent of additive manufacturing, industrial 3D printing, we can produce objects in a very different way. In traditional manufacturing, you remove material. You start with a big block of material, and you remove stuff until it looks the way you want. And then you attach it to something else, and then you build like a big machine or whatever. In additive manufacturing, you work very similar to the way nature works. So you grow things, you just put the particles in place that you need. And in traditional manufacturing, complexity is always your enemy, because if you have something that's more complex, you have to drill more holes and you do more work. So you always try to keep things as simple as possible. But in additive manufacturing, it's exactly the other way around. If something is more complex, but it uses less material, then it's actually cheaper. So this is the reason why in nature, a lot of the things are extremely complex because they're highly optimized. We humans right now don't optimize things like that. We don't create functionalities that are really complex because it's really expensive to build these things or even impossible. And so with additive manufacturing, you can build things that approach the complexity of nature. And that means that we can essentially approach the efficiency of nature. The things that we produce, they don't copy nature. They look sometimes natural, but it's not because we copied nature. It's because we used principles in the algorithms that just happened to actually come to the same conclusion as nature came. Yeah?
Can you give me an example of a typical product you would produce at Hyperganic?
Well, there's a really broad space of things that we do, right?
Other than rocket engines.
Yeah, exactly. So one of the things that is very interesting is, so because we produce objects with algorithms, we can produce objects automatically, obviously. And one of the areas where this gets interesting is in customized things. So you have things that should be customized to specific people. For example, in the medical field. I mean, you don't want to have a prosthetic leg that belongs to someone else. You want yours, right? You don't want to have a bone implant that belongs to someone else. You want yours. Or even broader field, protective gear, for example. You want a helmet that fits. Do you have a helmet that fits?
No. Of course not.
Okay,
it's your random helmet, right?
Exactly. So nobody has a helmet that fits. I have 5 kids. Can you imagine how much fun this is buying new bicycle helmets every year? It's ridiculous. So the human head looks very different for different people. So we should not try to squeeze our heads into some standardized thing. We should actually grow the helmet around the head. You scan a head, and then you grow the helmet around this head scan, and you produce a helmet that's specifically targeted for you. I mean, these are things that we, for example, do. And now the interesting thing is, once you have an algorithm that grows a helmet around a head scan, you can actually take other inputs into account. For example, imagine if you get the crash statistics back from the actual usage of the helmet. You can feed that into the algorithm, and the next helmet will actually take these algorithms, this data into account, and you will have an improved helmet. So over time, this helmet becomes better and better and better, just like nature optimizes things. Every tree that grows is perfect for that location, and every tree that grows after that tree is better than the tree before. That's just how evolution works. So if you create a feedback loop and improve the things, you can gradually improve things. And it's not natural. I mean, it's not clear that this looks like a bionic thing, but usually the complexity of these objects become more and more interesting. I mean, we have a helmet on our website, and it doesn't look like a typical bicycle helmet because it's kind of grown around the head, and it actually took the crash statistics into account. So, for example, it's much denser in the areas where you fall, and it's, for example, very light in the middle of your head because, I mean, nobody falls on the top of their head. They always fall to the sides, obviously. So you can use the middle to save weight and to increase ventilation. So that's a really trivial example, but fundamentally.
Yeah. But you know what? I just came off an event at South by Southwest, which is going on at the moment. And taking now into consideration what is waiting for us in the very near future when it comes to all the transformations we're undergoing or which society will be undergoing in the next couple of years. Take, for example, wearables. So it could be super interesting to see the helmet you've been talking about, children's helmets, for example, grow with them as they age, because you get data input from your wearables, for example. So you could, with every year, fabricate or manufacture the right helmet for your kid because it grows.
Yeah, absolutely. And so I don't think in 5, 6, 7 years, we are going to wear products that are not custom made for us. It's just such a ridiculous interlude, actually, if you think about it, because 100 years ago, a lot of things were specifically tailored to us. And then came the Industrial Revolution. All of a sudden, we all have to deal with the same clothes sides and the same helmets and all of these things. So, I think this is going to happen very quickly. But, if you look at the big picture, this is actually not the most important thing. The most important thing is once you've created an algorithm that creates an object, you can create another algorithm that creates a different object. And now these two objects, they can start talking to each other when they need to be combined. And one of the cool things about software is you start with simple modules and then you build something bigger and something bigger. And all of a sudden you have this giant software thing that can do amazing things. I mean, we have literally software that can fly airplanes, right? But interestingly enough, we don't have software right now that designs airplanes. And an airplane is an incredibly complex thing, but a human built it. A human engineer, or actually a number of human engineers created it. So, it can be done. If a human can create it, you can also create an algorithm that can do the same things. And so what we are headed for is almost like a singularity in construction where things will be fully automated. So where you can literally say, I mean, like you were kind of tongue-in-cheek at the beginning. You said, do I just say I want a spacecraft and how far it should fly? And boom, out it comes. But, frankly, this is where we're headed. I don't know how long it's going to take, but it's not going to take forever because it's very clear how you build it. You build it one piece at a time, but you start with one piece of the rocket engine, and then you add another piece of the rocket engine. At some point, you have an entire self-configuring system that creates the entire rocket or the entire airplane or the building or whatever you want. And this is really...
What do you think? Would an algorithm, if you asked a machine to design a car, say, of course, it's not possible at the very moment, but maybe in a couple of years. So what do you think? Would an algorithm come up with a car in the shape of a car? Would it still have four wheels, or could it look completely different?
That's the fun thing. We have absolutely no clue. We have no clue what the stuff will look like. I mean, I always give the analogy to the computer industry, right? When the people designed the first microchip, that was amazing because this complicated thing that had to be assembled from lots of different pieces could all of a sudden be printed on a wafer. But people assumed that computers that had microchips would basically do the same things that the computers that existed would do. So basically calculating things. Nobody saw coming that we would be using the same microchips today, to communicate with each other over this podcast, or to fly to the moon, or to maybe just tag by clothing and put a microchip in the clothing tag. So people had no idea what would happen. They just extrapolated forward and said, oh, that's great. I don't have to turn the crank anymore to calculate numbers and the cashier system. I can do it electronically, but they didn't envision the world that we live in today, with microchips being ubiquitous. So if you use algorithms to build functionality, you can include functionality for free. Fundamentally, just like you can include a microchip or computing for free, more or less today. The amount of money that you have to spend on engineering becomes basically zero. So how would the world look like if you could include functionality for free in everything that is around you and print it for free? Because again, the 3D printer doesn't care how complex the object is. So if you have automated manufacturing, if you have manufacturing that doesn't care about the complexity of the object that is actually manufactured. If you have engineering that doesn't care about the complexity and doesn't care about how much functionality you add. I mean, how functional and interesting will all these objects around us become, and what will the world look like? And honestly, I have no clue, but I just know that it's going to be very interesting.
3D printers have been available for a couple of years now. So if I wanted to buy a 3D printer at the moment, it's very easily affordable. It's a couple of hundred euros. But the problem is it hasn't really taken a foothold in our popular culture to use 3D printing technology in our lives. And do you have an interpretation why that is?
Yeah, I mean, you're right. I mean, 3D printing has been around for 30 years now. And there was this huge hype around 3D printing during the MakerBot years. That's really, I mean, we're kind of in the trough of disappointment. If you look at the Gartner hype cycle, it's because we are focusing on the wrong technology there. So everybody knows the cheap 3D printers that print little plastic parts. And these have come a long way. And you can do a lot of cool things with these. But the interesting thing is really not that technology. It's the industrial technology where you print metal parts and polymer parts that are comparable to injection molded parts. And so there's this huge field of industrial 3D printing. And here we're not talking about a couple of €100, for a cheap plastic printer. We're talking about massively expensive equipment that is used for serious manufacturing. And quite frankly, I mean, these machines and these factories, these digital factories that we're building, they are not going to be inexpensive. They are not going to be cheap. I mean, if you look at a microchip fab, these cost sometimes billions of euros to build. This is actually a good model for where we are headed with manufacturing. I don't think we're headed for cheap distributed manufacturing in your home. We're headed for complex factories that incorporate 3D printing, that go beyond 3D printing, but that are highly complex machinery that can produce really amazing technical objects. I mean, you can literally...
Say, Lin, what's the difference between a factory as we have it today and let me extrapolate the Hyperganic factory? Where's the difference?
A factory today is a highly specialized thing. When you want to produce an object today, you not only have to design this object, you also have to design the machine that builds the object, or at least the tool in the machine that builds the object. In the future, these factories are going to be more generalized because additive manufacturing, 3D printing allows you to generalize things. As long as you use similar materials, the printer doesn't care whether you print an aerospace part or a car part or an ornamental object for an art installation or something like that. So these factories are going to be way more generalized. Again, here, the model is also the microchip industry. A microchip fab doesn't care whether it creates a microchip for a phone or a car or some other specific thing. You have a standardized production process. You have very vast differences in the designs, but you have the standardized production process that fundamentally always creates the same thing. It's just the designs that change. And this is what's going to happen with digital factories, with hyperganic factories. And the interesting thing about this is that you can, because they are standardized, you can decentralize them. You can move them closer to the consumer. You can produce objects that we call digital physical objects. So objects that are designed and trade it digitally, but then manufacture at the last mile close to the consumer. But last mile, not in terms of in your home, maybe in your city, maybe in your state, maybe in your country, but not in faraway places where labor is cheap, because these factories don't have any labor in there.
Say, Lin, how long till we see the real Star Trek replicator? I mean, like this is something that will be the epitome of your dreams, right?
Yeah, you mean replicator, please make me a cup of tea.
Make me anything, yes. Make me a cup of tea, make me a smartphone, make me my car keys because I lost them.
Yeah, it's going to take a long while. So a lot of manufacturing processes need to be integrated, and it's never going to be a small device you put on a spacecraft, I fear. So we may never actually get there, but we will get to a point where a lot of different manufacturing processes are integrated. And you can create extremely functional and interesting objects and very different objects from the same factory.
What's the craziest thing that can already be printed?
We have a lot of really crazy projects. I mean, some of the things involve stuff like carbon capture from the atmosphere, for example. That's a really cool thing. I would still say, and maybe that's just my family, some of the coolest things that we create are space hardware. We will have a follow-on object that we will present very soon to the 4-year-old rocket engine that we introduced in 2018. And it's going to be mind-boggling. And that's one of the coolest objects that I've personally ever seen. I mean, one of the interesting things, and maybe that's not an object, but something to think about. One of the cool things about additive manufacturing 3D printing is that you can now all of a sudden modulate and change the material that you're working with. There's something that nature does all of the time. I mean, if you look at a tree, I mean, where does the trunk stop and the branch start? And where does the branch end and the leaf start? You can't see that. It's gradually changing. And it's all actually the same material fundamentally. The tree just changes the material properties as it grows. And one thing becomes a green leaf, and another thing becomes a really sturdy trunk, and then parts are the bark. And we can do these things now in 3D printing. So we can actively change the material properties. And this is something that we've never been able to do as humans. We've always looked at different materials and selected them and then combined them and glued them together or something like that. And we can now gradually change things. In my TED Talk, in the speech, I used one example. I showed people a piece of chalk. It said this is crumbly material. And I showed them a seashell. And I asked them what the difference is in terms of material. And the funny thing is, there is no difference. Chalk is actually made from seashells that died millions of years ago. So it's exactly the same material. But the difference is, as the seashell actually grows, it puts the little pieces of chalk into place with protein glue and creates these microstructures. And these microstructures make the seashell incredibly hard. It's almost impossible to break it. So it's this crazy material that is actually not a crazy material. It's the material plus the structure that changes and transforms the original crumbly material into something that's harder than most of the man-made materials. So we can do stuff like that now in 3D printing. And it's just mind-boggling. And it will give us so much more, it will give us so many more opportunities in material science and what we can do with these materials, that this alone is its all entire own subject.
Lin, I'm highly fascinated by what we're talking about, because I can already see so many applications and so much potential. At the same time, I'm asking myself as to if you or adaptive printing in the first place is enforcing the final showdown on Earth when it comes to the exploitation of resources, meaning we're speeding up production now by algorithmic processes. We've seen the exponential growth of information based on the exponential growth of software and the possibilities that come along. Now we bring the same logic into manufacturing. So how does that make this planet stay afloat, so to say, with humans on it without exploiting it?
I would say it's actually the one thing that we need right now, because the technical solutions that we have to environmental problems are completely inadequate at this point. We don't have effective carbon capture. We don't have extremely lightweight materials and all of these things. So we need exactly that acceleration to solve these challenges of our times. Now, for example, if you look at the material modulation that I just talked about, gives us the opportunity to actually build objects that have different properties from the same base material. So this makes it much easier to recycle things, because you don't have all these problems of stuff that is glued together and you can't separate anymore, and the only thing you can do is burn it. So there's this huge opportunity that comes with this acceleration for innovation, for shorter cycles, to actually finding the optimum solution. And then one of the interesting things is also that, as I told you earlier, in traditional manufacturing, material usage is actually not something you optimize for. You optimize for production cost. So if you have to drill another hole to reduce the amount of material, you will probably not do it unless you absolutely have to, because it increases cost. Now, if you just put the particles in place that actually make sense, you will use significantly less material than you did before. If you produce stuff in factories that are fully automated and are close to the consumer, you reduce shipping emissions. But first and foremost, and that's the really critical thing, we can accelerate innovation so we can free the human minds to come up with the direction for these innovations. And we can direct these innovations towards, what we actually want to build. And that, I hope, it's a future that's sustainable, that's positive for humanity, where the human is in the driver's seat and can enjoy an intact environment. So I think this is exactly what is needed. And it's not, we still need the engineers. We still need all the bright minds to actually ask the question, what should we build? But we are no longer limited by this slowdown that comes with, oh my God, I don't want to redo the whole thing again because it's going to take me so much time to re-engineer it. This is currently the situation. If you want to do something innovative, you have to ask a person to throw away all the designs that they did in the past and come up with all this stuff anew, which is a tedious and frustrating process. And a lot of people don't want to do that. So if you ask a computer to do that, they don't care. They do it 1,000,000 times if you want to. And they will come up with way more optimized and way more complex, way more functional, and probably also more beautiful things than what we've created in the past.
Wonderful. Lin, we do have a fun tradition at the end of our podcast, and that is, as we are a space cafe podcast, coffee house, so to say, we love espressos, and now we're asking you, would you like to share an espresso that is a quick shot of inspiration with me and with the audience? Inspiration, you pick the topic, a quick shot you would like to throw out into the world. Something perhaps that fascinates you or that you deem extremely or utterly inspiring.
That's a tough one. I think maybe I want to throw this one out. I think if you look at interesting people's lives, you realize that they made strange seeming decisions at points in their life. And they seem to be kind of nonsensical and maybe bold. But in retrospect, they were exactly these things that moved everybody forward. If Elon hadn't thought that he wanted to send a greenhouse to Mars, he would have never gotten into space and we wouldn't have done all these things. And there's so many other examples. You look at interesting people. And the thing that I always ask myself, what assumption can I throw overboard that is holding me back and that is preventing me from making this crazy seeming decision that could move us to the next level. So this is just something I want to throw out there. A lot of people live their lives in a very conventional way. And I think the main thing they're missing out is this, hey, let's do this crazy thing for once and see what happens. And honestly, I've tried this many times in my life and I've never regretted it because something amazing always happens. So I actually constantly ask myself, am I still doing that? Am I actually making decisions that are in some way crazy enough? And if I'm not doing it, what could it be? Maybe this is something that we should all ask ourselves constantly and more. And if we do that, maybe the world will be a much more interesting place. I mean, does that make sense?
Absolutely. Thank you so much, Lin, for your time and for your inspiration. It's highly appreciated. Thank you.
Yeah, thank you, Marcus. It's been a blast, and thanks for having me.
It's okay to be a little crazy now and then, right? No, let's back up. We'll delete every now and then. It's okay to be crazy. It sounds a lot better, right? I hope you enjoyed this episode as much as I did. If you want to learn more about Lin, we've put together some links in the show notes. In general, more information from the Space Corner can be found on SpaceWatch.Global, as always. If you do not have time for all the fascinating stuff on the internet like I do, sign up for the newsletter, a condensed, quickly digestible collection of everything you want to know about the space industry, promised, and possibly a little more. Head over to the subscribe button at SpaceWatch.Global if you like. So, that's it for today. I'm still shaking my head at my boring life compared to Lin's uncle. No intelligence agencies on my tail, no wild animals, no other adversaries. But you know what? I like it that way though. Thanks for being here with us today. See you next time.